So I'm intending to add a feature that I'm going to call the sleep mode feature on the brain circuit right there. So the feature is going to be as the name suggests, the feature is going to be shutting down the system once a trigger or once something has been done. I want it to be in two stages. There will be a manual one which is going to be containing a push button. Once you press that push button, then the system is going to be shutting down slowly. Then there will be an automatic one which will be right here at the input of the priority selector. So at this input we are going to put an OR gate. That OR gate is going to be detecting if either of the input or if all of the input is going to be on. If all of them are off, then the OR gate is going to give a zero output. That zero output is going to be inverted and it's going to trigger a circuit which is going to be in this part of the breadboard called the shutdown sequence. Is going to trigger a countdown which is going to activate the shutdown sequence to shut down the entire system once there's nothing there's nothing to be, or there's nothing the circuit is working on, meaning that there's no input which is placed at the input of the priority selector. But if an input comes either from either from a light sensor or a motion or a temperature sensor, then the shutdown sequence is going to be cut off and the circuit will continue operating in its normal state. So the reason as why I'm recording this is, you can see I've not even started the shutdown sequence. This is only the trigger, which we did last time, which detected a special case once two or more inputs are placed on the priority selector. Now, the reason as why I'm recording is because I've been working on this circuit, the sleep mode circuit, the sleep mode circuit for some quite period of time, and I'm not yet through, or I'm not yet having a breakthrough, because the system is quite, or the logic is quite hard. I've been trying to brainstorm or to see where I'm going wrong or how I can design it to be well. So the problem also, so this top part is the explanation of how I want the system to be. So right here you can see the OR gate. So this OR gate detects if either of the input from or is entering the priority selector, meaning that the circuit is active. If it's not active, then the OR gate is going to give a zero output. That zero output is going to be inverted first into a 1 output, into a 1. That one is going to trigger a monostable NE555. The monostable NE555, which is set to be on a long period of time, maybe I use a bigger capacitor, is going to be acting as the timer for the shutdown sequence. So that timer is going to turn on. It's going to turn on an astable mode, NE555. The astable mode is going to act as the clock of CD4017, which is a decade counter. A decade counter counts from number 1 to 10 once a clock signal is placed. So as it is continuing to count, once it reaches the 10th output, the 10th output is going to trigger a bistable mode. It's going to trigger a bistable mode NE555. Once the bistable mode NE555 is triggered, it's going to act as the input of this last circuit. So the bistable input is going to enter the base of this transistor. It's a BC547 or any other NPN transistor that you have. Yeah. So once it enters this point, now from the supply, which is 5 volts, rather than going to the brain circuit, it will choose the path of less resistance, which is this path to ground. Yeah, rather than going this way, as it's usual, it's going to go this way to ground. So that's the shortest path to ground, not to the brain circuit. That means that once an input is placed, then the brain circuit will shut down. There will be no power supply to the entire circuit. So that's what I'm intending to build. So this is the circuit that I want to build here. Yeah. So the problem is that the trigger circuit, I want it to give a 1 trigger. That 1 trigger is going to be by this RC plus the Schmitt trigger circuit. So this trigger was initially designed, or I initially made it for it to detect a special case at the input of the priority selector. Either 2 or more inputs are on to trigger the decision making part of the circuit. But I want to put another separate trigger which is going to start the shutdown sequence, and that's what I'm having a problem is, because under normal conditions, if I can just place this, you can see, if let me just do it again. If I place this here, okay, this one is low. Let's try another one. Let me just place it there. You can see that short pulse, that short blink like that, and then goes off. Let's do that again. Okay, I want it to be stable, so for it, you can see that short pulse like that, and then goes off. So that's the pulse of the decision making part of the circuit. But I want to separate a pulse for that, say that side, for that decision making, and a pulse for the shutdown sequence. And the problem is, for this circuit to work, you need to power both the 10k resistor which has the RC, this is the RC circuit, and to power the Schmitt trigger IC itself at the same time. And that's the problem, because once I turn on this, if I put another circuit like that here, then it's going to be triggered as well. Yeah, meaning that if a special case has been met, then it's going to trigger a shutdown sequence, and that's not what we want. We want to separate those two pulses. And yeah, if I had initially thought to put this resistor like that, and right here we are going to place the input from the side that we want. Maybe either we can put this input to be the input for the decision making, and another one here for the input of the shutdown sequence. Now the problem with this this configuration, if I can just turn it on, let's see what happens. If I turn it on and I want a trigger for maybe a shutdown sequence, yes, it's going to produce that trigger, but this other output is going to be like this. It's going to remain on like that, and that's a problem. Yeah, that's a problem. That's not what we want. We want it to be off once the other one is being triggered, and we want this one to be off as the other one is being triggered. So yeah, yeah, I'm going to say it again. The reason is why I'm making this video, because I know you guys are very talented, and I know you are there are breadboard experts out there. Yeah, so help me out here, and try to brainstorm with me on the comment section. Try to help me think, or yeah, to think of other ways in which I can produce that short trigger, or separate those two triggers for the decision making part of the circuit and for the shutdown sequence, because everything is okay, only that's what is making us to be stagnated. Yeah, so yeah, thank you very much guys for watching. Please subscribe to Tronics Energy, and I hope to hear from you, and I hope to see you next time. Goodbye.